Today, I'm going to be talking about Firebase. If I can, there we go. What's the hotkey to present or full screen?
Click this thing.
It's hard to find it. Right here?
No,
To
to the left.
the left.
To the right.
To the right.
To the right a little bit more.
A little more.
Click.
Click. Yeah. Okay. Raise your hand if you have heard of Firebase. Raise your other hand and keep your other hand raised if you've heard of Firebase 2.0. Now, let's all do the wave. All right. So Firebase 2.0, you may be wondering if you haven't heard of what Firebase 2.0 is. About 2 years ago, Google bought Firebase, and then it seemed like Firebase kind of coasted as far as features goes. What Google was doing was supercharging Firebase. Firebase consisted of 3 products. There was originally database, hosting, and auth. Just kind of 3 basic things that let you build real-time apps without a backend. Kind of that backend as a service thing that Ryan Doan mentioned earlier. Firebase 2.0 is Google taking the Firebase, their product, the team, and adding a whole bunch more product and team to it, and it has now become Google's premier platform for building mobile apps. And instead of just 3 products, it's now like 15 products. It's a whole suite of tools. So I guess I was introduced a little by Dave, but a little more about me. At Google, I'm a developer programs engineer. I work in developer relations on the Google Cloud Platform. So very external facing, lots of open source presenting. I do primarily Node.js stuff. So some of those Node.js projects on the Google GitHub organizations, a lot of those are me. I also have Angular Cache and JS Data if you're interested in those. Today we're going to talk about quickly some of the Firebase basics, and after those we'll move into like some of the cloud integrations and how you can use the Google Cloud Platform to supercharge your Firebase apps. First though, I want to tell a little story. You know, a lot of coders like to do side projects, me included. So I did some side projects, and for these side projects, I needed to set up some servers, DigitalOcean or something like that, virtual private servers. I taught myself Chef. I wanted to make sure they were secure, they were hardened, they were up to date, and that I could recreate them at a moment's notice, and that was a lot of work. And then I tried Firebase, and I didn't have to do any of those things, but I could still create the same side project, the same features, the same functionality from the user's point of view. And so that's backend as a service. It eliminates the need to take care of those DevOps-y things yourself. So Firebase is a platform for helping you develop your apps and grow your user base and then earn revenue. And that's what the suite of products is designed to do. So here's a quick overview of the products themselves. You're familiar with, or if you have used Firebase, then you know about database, you know about auth, you know about hosting. But Firebase 2.0, which was announced at Google I/O earlier this year, adds a whole suite of products. Some of them are specifically for the mobile side of Firebase. So if you're developing Android and iOS apps, then things like invites and dynamic links, app indexing, notifications, they only really apply in that mobile space with the mobile SDKs. So, but today I'm going to be talking mostly about things that apply to web programming. It's JavaScript conference. So I'm going to introduce Firebase Storage, and I'm also going to talk a little bit more about the compute options that are available to you through Google Cloud Platform to complement your Firebase app. So these are just some of the we're just going to focus on just a few of the products. Firebase Storage itself was a much requested feature. You could stick binary data into Firebase, but it just wasn't very scalable. It didn't work very well. Firebase Storage is now a first-class product for storing blobs and files in the cloud, and it's backed by Google Cloud Storage, which is the same infrastructure that powers things like Google Photos and Google Drive. Google Cloud Storage is globally replicated and immediately consistent on the individual file level, and it's amazing and fast. Analytics is mostly for the mobile side of things, but what you can do with Firebase is, depending on your pricing plan that you're are participating in, Firebase can export all of your raw event data right into BigQuery, where you can run all of the analytics you'd ever want to run on a petabyte scale product. So quickly into the Firebase basics. Because we're kind of short on time, I'm not going to be able to do much live coding, so I'm going to do what's called live uncommenting, and it'll get the code out quicker. So the idea with the database is that you have multiple clients, they load your app, and then changes on one client can be quickly propagated to other clients through the real-time database that is Firebase. Firebase is the backing store. So some quick little snippets of code. Hopefully that's all readable. It's pretty quick and easy. You load the Firebase JavaScript library, and you basically select which part of the database you're going to be accessing, reading and or writing. Your database is basically a large JSON tree. So if you want to load top-level nodes, you could potentially be loading a lot of data. So when you're structuring your data with Firebase, it's recommended that you flatten it as much as possible, and don't worry about duplicating data. Just duplicate data as much as you want. As far as offline functionality goes, in the Android and iOS Firebase SDKs, you can enable automatic offline disk persistence for the data. So if the user loses connectivity and closes the application, having made some changes, when they then reopen the application and come back online, those changes will be synced to Firebase. For JavaScript and the web, it works within the session that's active, but it doesn't quite work yet with disk. So it doesn't use local storage or IndexedDB yet. But if the user loses Wi-Fi and they have your tab open in their browser, and they can continue making changes to the data. And if they regain connectivity, those changes will be synced to Firebase. To kind of warn the user that they might lose unsaved data, you can use the browser's hook to pop up in that, hey, you're navigating away. Are you sure you want to lose these unsaved changes? And then these snippets of code right here are how you could manage like online and offline presence. A single user could open your app in multiple browsers or multiple devices, and sometimes you want to be able to track who's online, who's not online, when were they last online. And with these short lines of code, you can easily do that for all of your users and get that sort of presence functionality. Authentication, Firebase ships a bunch of auth tools with its SDK to quickly allow users to log into your application using various OAuth providers, Google, Firebase, Twitter, GitHub, and you can hook it in your own authentication with the JIT tokens and things like that. And it also supports anonymous authentication. Here's anonymous authentication. This allows you to at least track the users as they're visiting your application. And if they then convert to like an actual user, Firebase can transfer anything you gather with the anonymous user into your actual user. It also handles letting users log in with multiple providers and resolving them to the single unique user. It's pretty easy to get started. You just drop in the Firebase JavaScript file from the CDN, and then you just initialize it with some configuration. If you go to the Firebase dashboard, you can actually get this code generated for you with all the correct variables inserted for you, and you just paste it into your app. Live demo number 1. Let's hope this works. So here, I actually have an app that I've created. And what I'm going to do is I'm going to quickly go over to the console. Let me set this down real quick. Here I've installed the Firebase command line tool, and it's very small. Oh, I already typed Firebase twice. So Firebase, the CLI lets me, first you initialize an application, then you can serve it locally. And I have it serving now. So I'm going to open my browser. And it's now running. So it doesn't do much right now. It's a very simple demo. But what I'm doing is basically they're little chat messages. So I'm going to say, hi. Unfortunately, this data is only stored in my browser. I haven't plugged Firebase into it yet. So if I refresh, the data is gone. So this is the live uncommenting part of the demo that I'm going to do. So I switch over. I used Angular 1 for this just because you can do stuff pretty quick with Angular 1. Angular 2, I think, requires a little more setup. Anyone see comments? Oh, it's the wrong file. There we go. So here I have on the scope just an array, simple array. And whenever I add the messages, I was just pushing the object onto the array, and it was being re-rendered. To activate Firebase, I'm going to uncomment all of this. And what I do is I say, OK, Firebase, I'm going to do some database stuff, and I'm going to grab the messages node. And then here, I'm going to query. I want to do a query on that. I want to pull, say, the most recent 10 messages. So I use this limit to last method, and I pass in a number. This happens to be 10, stored in that variable. And then right here, this handler function that I've defined, I take that query and I say, whenever a new message is added to this array, I want to be notified. It doesn't matter if I did it. It doesn't matter if some client on some other browser did it. I want to be notified. So in Ryan Doan's talk earlier, he showed how Horizon was doing the change feeds and the watching, and you get notified as data is pushed to the browser. Same deal here. So this will actually be executed once for these first, or for the most recent 10 messages, and then for any new messages that arrive. Now, instead of me pushing my message onto the array that's on my scope, I'm going to grab that database node that I created earlier, and I'm going to push my messages right onto the array, and that's all you have to do to write it to Firebase. So I'm going to go back to my app, refresh. I think I probably broke something. Oops. Typo. Yep, there's an extra S. There we go. There's a message. And if I refresh, it's back. So this app is running locally. I'd like to share it with everybody. So I'm going to quickly go back to my terminal. I'm going to close that. I'm going to run Firebase deploy. And this is going to take all my static files, deploy them to the hosting, and it's done already. So I refresh the real app. It's got my message, and there's a short link if anyone wants to start chatting to everybody else. It's bit.ly/UtahJS chat. It'd be interesting to see everybody try it. So while you're trying it, again, it's bit.ly/UtahJS chat. I'm going to quickly flip over to the rest of my presentation. There we go. Bunch of anonymous cowards. That OK Google thing sometimes just gets annoying. It's always listening. So quickly, back to my presentation. So Firebase Storage. This is going to go into the second part of my demo. So Firebase Storage allows you to upload arbitrary blobs and files to Firebase. And it's backed by Google Cloud Storage. So while your users might be uploading files in your client-side app, you're using the Firebase SDK to do that, you can actually go find those files in the Google Cloud console, the Google Cloud Platform console. And you can also interact with those resources using any other service of yours, any other workers that are on the server that you're using the Google client libraries to talk to cloud storage. It's all the same data, and you can get access to it however you want. So here's a quick little code snippet that shows it looks very similar to writing data to the database, except you're writing files. So I'm going to blaze through that. Just like you have rules that you can put on top of the database as far as who can write what and where, you can do the same thing for Firebase Storage. You know, which users are allowed to write which files to which locations, and which users can read files from which locations, and different things like that. Firebase Analytics, I'm going to go through this quickly just because it applies more to mobile development, which I'm sure some of you are involved in, but we're talking mostly about web today. It can quickly give you a lot of insight into your user base and how they're interacting with your applications. You can then take this data, you can get custom events, track your own custom events, and then eventually export it to BigQuery for some heavy analytics, and if you need to do that. BigQuery is Google's mega ultra petabyte buzzword scale data warehouse, and you have a free monthly quota of 1 terabyte. And what I would do is I would recommend everybody find if you go Google the Google Public Datasets program. With BigQuery, the BigQuery team is hosting a bunch of public data sets that you can go run your own queries on. If you're on Medium at all, you probably see Felipe Hoffa is constantly writing articles doing BigQuery stuff. One of the most recent ones was answering the comma or spaces versus tabs debate, because right now all of GitHub is in BigQuery. Well, it's replicated to BigQuery, and so all of the code is in BigQuery, and you can actually go query all of the code on BigQuery, and you have a free 1 terabyte quota per month, so you can go start running your own queries against that public data set, and maybe you can answer is it 2 tabs or 3 tabs, or I don't know, some question. Another one I saw was what are the most popular NPM packages, and they did that by running some BigQuery queries. And that's kind of what the BigQuery dashboard looks like. So this is the second part of the app, and what the second part of the app is it lets you log in with GitHub. In the case of my demo, you log in with GitHub. And then it's a photo storage app that then processes the images that you upload with the Google Cloud Vision API, which can do a bunch of different things, like it can do OCR, it can detect labels, landmarks, faces, colors, explicit content, a bunch of different things. And that's what the demo is going to do. So here, for each image that's being uploaded by the user to Firebase Storage, I'm also creating a node in the database just so I can track some meta information about the image, like the stuff from the Vision API. Oh yeah, there's more stuff about the Vision API like I was mentioning earlier. The Vision API is one of the Google Cloud's machine learning APIs, kind of like the natural language API and the speech API. We just have a bunch of machine learning models that we've built on and trained on, epic amounts of data that you can then just use in your apps. So live demo number 2. No Giphy support. I'm sorry. So I'm gonna log in, and I already accepted the terms, so it didn't show the GitHub screen. But so I logged in, shows my picture. I'm gonna go to the profile. I'm going to upload a picture real quick. I'm going to upload my mug. It's my face. Uploaded my face. Now notice the image appeared instantly. I wanted to make sure the user could see that right away. Some processing is still happening. And this processing is not happening in the browser. A lot of questions have been asked over the years. What if I want to do something that I can't necessarily do in the browser? How do I do that with Firebase, right? Well, I guess the only answer until now was you had to run your own server. But Google has a new product called Google Cloud Functions, and as you can see, the processing finally completed. The function wasn't hot, so it probably took a little while. But Google Cloud Functions is in alpha. And as was announced in Google I/O in May, I believe, the Firebase team is working with the Google Cloud Functions team to bring a easy-to-use, lightweight compute solution to Firebase. It's not around yet, but you can use Cloud Functions, and that's what I'm using in my demo. So as you can see, I uploaded the image, and then in the background, what my Cloud Function did is it was triggered by the file upload, because when I deployed my Cloud Function, I said, hey, I want you to be triggered by file uploads. And then the function ran, and what it did is it called the Vision API, and when it was done, it took the metadata that it got back from the Vision API about the image, and then it wrote that to my Firebase database. So I can quickly show that in the code. Here we go. So that was that other file that I had accidentally opened. So this is my function. So I import the Firebase client. Is that readable? Let's make it a little bigger. I also import 2 of the Google Cloud client libraries, one for Cloud Storage, one for Cloud Vision. I initialize the Firebase client by pointing it to the service account that is available in the Cloud Functions environment, which authenticates it with Cloud APIs. I also point it to my Firebase for my app. And then right here, what happens is down here, when I deployed my function, I said, I want to deploy a function called process image, and it deploys the function, and then it's executed. It's given the file that was uploaded. I take that file, I grab some parts out of its URL because when I name files, I stuck the user's ID so I know whose file it was. And then what I do is I call this analyze function, which is up here, calls the Vision API. I'm only concerned with 3 features of the Vision API. I'm looking for faces, landmarks, and labels. And then what I do is I get those back. And then with Firebase, I then go update the image itself with that data. So I'm going to flip over to my console real quick. Wrong one. So in my database, those are all those messages. And I can scroll down to users, and I can see that here's a node where I added an image. And here we can see that it was updated. That mug of mine that I uploaded, it detected facial expression, person, face, male, portrait, and that there was one person in it. No landmarks, unfortunately. The cool thing about this is if I go over to storage, we can see the images that have been uploaded. I think one of them is me, this one. And there's my mug. So this is kind of the Firebase console. But since it's part of Google Cloud Platform, I can flip over to Google Cloud Platform. And I can go to storage, and all the same images are there. Images. And they are Google Cloud Platform resources. You can interact with them with any of the Google Cloud Platform APIs and client libraries. So this is supercharging your Firebase app. And to quickly continue and finish up my presentation, sometimes there are things you need to do that you can't quite do in the browser. So you need a compute option. And there's a compute continuum. Google Cloud Platform offers a number of hosting options for doing cloud compute. Infrastructure as a service where you're paying for things like compute engine, raw VMs, where you do whatever you want with them. Next up on the abstraction ladder is hosted Kubernetes, which is the container engine. So Docker images being orchestrated, self-healing system, rolling updates. Next layer of abstraction is our platform as a service called App Engine. The old App Engine is called App Engine Standard. It's been around. It's actually the oldest cloud platform product is the old App Engine. The new one is called App Engine Flexible, and it is Docker-based. So you can actually bring your own Docker image, and we will auto-scale it for you. You just give it to us, and we'll run it. App Engine Flexible provides features like instant rollbacks to previously deployed versions, live migrations. You can split traffic between versions, and a whole bunch of other things. And then the highest level of abstraction is the new alpha Google Cloud Functions, where you just write a JavaScript function, well, it's Node.js, and then deploy it. And we run it and execute it whenever it needs to be run and executed. And you don't have to worry about anything else. So, supercharged your Firebase app with Google Cloud Platform. It's a whole suite of products, machine learning APIs. If you have any questions, come find me. I'll be outside. I'll just go stand out there for a little bit. If you have any questions, JM Dobry on Twitter and GitHub. Thank you very much.
Thank you. Thank you, Jason.